All right, so we're starting a new chapter over polygons and quadrilaterals. So this first section here, there's a lot of vocab, so follow along with me, fill in the blanks in your notes. Let's first define what a polygon is. So it says a polygon is a plane figure that is formed by 3 or more segments called sides, such that the following is true. And it gives you 2 things here. First one, each side intersects exactly 2 other sides once at each endpoint. Okay, so you can clearly see, like in this example over here, they're not intersecting at their endpoints, so of course it would not be a polygon because you got this little gap right here. And then number 2 sounds a little weird. It says, no 2 sides with a common endpoint are collinear. So that just means like these would be 2 sides with a common endpoint, and they're not in a straight line. Okay, of course we'd need to close it up, and boom, you'd have a polygon. If they have a common endpoint and they are collinear, it'd be like, here's a side, here's another side, but we would consider that just one side, not 2, because they are collinear. Okay, so, oh, and then also when it says a polygon is a plane figure, that means like a 2D surface, not 3-dimensional. Okay, so here's some examples of polygons right here. Straight lines, nothing wrong there. These would not be polygons. Here, if you notice, it says that, where does it say? Formed by 3 or more segments called sides. Obviously right here, this is not a segment. That's a curve. So that would not be a polygon. Over here, this one also, I mean, technically you could say each one of these individual are polygons, but together this would not be a polygon. Okay, and then of course we went over that one. Okay, some more vocab here. Polygons can be identified 2 different ways, which are concave or convex. And most of the ones that we deal with are convex polygons. All right, so it says a polygon is convex if no line that contains a side of the polygon contains a point in the interior of the polygon. Also kind of a weird definition. Let me just give you a visual to explain it. So these are convex polygons. Over here, these are what we call concave polygons, which you can go ahead and fill in those blanks. We say if it's not convex, it's called concave. So let me explain the concave part. If you can pick 2 endpoints in your polygon, like here and here, and connect them, and you have points in the interior, this blank space right here, that's concave, right? Like over here I can do that. I can pick 2 endpoints, connect them, and I've got these interior points right here, the space. That's concave. It's basically things that are angled into the polygon, angled inward, make it concave, like it's caving in almost. Over here, that's not going to happen, right? If I pick 2 endpoints, I just have my segment, right? I don't have any blank space in between that. So convex, concave. All right, some more vocab here. So it says a polygon is equilateral if all of its sides are congruent. You guys know this. A polygon is blank if all of its interior angles are congruent. So if the angles are congruent, we say that is equiangular. All right, so if a polygon is both of those things, equilateral and equiangular, then, and this is a new word, we call it a regular polygon. So if all of its sides are the same and all of its angles are the same, it's a regular polygon. Otherwise, we would just say it's irregular or not regular. Okay. Vertices of a polygon, those are points where the segments meet. You guys have learned that one before. So for example, in our picture here, we would say points A, B, C, D, and E are all the vertices of this polygon. And if we said that all of these sides are congruent and all of the angles are congruent, we would say that is a regular polygon. And we could also say this is a convex polygon. A little bit more vocab. We say consecutive angles or sides are angles or sides that are right next to each other. Consecutive, kind of like if you had consecutive days of the week, would be like Monday, Tuesday, and Wednesday, right? Right by each other. Monday and Friday would not be consecutive. Okay, so we would say, for instance, angles C and D, those would be consecutive angles. And you can also say that with segment length. So like BC over here, and CD, we would say those are consecutive sides because they're right next to each other. Right here is a diagonal of a polygon, is a segment that joins two non-consecutive vertices. Okay, so if I said, draw all the diagonals from point A, well, I wouldn't go from A to B. Those are consecutive vertices. That's not a diagonal. You have to join it to all its non-consecutive vertices. So we'd say AC and AD are the only diagonals from point A. Now you could draw more diagonals from different points, but you'll get the same number actually. Like if I picked point E, I'd have a diagonal here, and I'd have a diagonal there. There's just two. And as it says here, it says the two diagonals of the above polygon are AD and AC. So if I said like draw all the diagonals, you don't have to draw all of them. You just need to pick one vertex and draw all the possible diagonals from that vertex. That's typically how we'll do diagonals. And diagonals are important because they're going to help us figure out the interior angles of a polygon, which we'll do in a little bit. Okay. We classify polygons by the number of sides that it has. So for instance, if a polygon has 3 sides, we call that a triangle, as you guys know. I would like for you to pause this and fill out as many of these as you can. Let's see how much you remember. So pause. I'm going to go ahead and fill them out. So 4 sides would be quadrilateral. 5 sides, if you remember that, is a pentagon. 6 is a hexagon. 7 sides, we call that a heptagon. Sometimes called a septagon also. Septa, believe that comes from Latin. We use the one that comes from Greek, which is heptagon. 8, octagon. 9 is a nonagon. 10, decagon. 11, this one's probably new to you guys. That's called a hendecagon. It's a weird one, I know. 12 is a dodecagon. And then there's names for ones after that, but we're not using those as much, so we don't need to learn those names. So in general, if we're talking about a polygon with more than 12 sides or really any sides, you can just call it an n-gon. And then in general, all of these are polygons, a figure with many sides. At least 3 anyway. Pause, let's practice some before moving on. All right, so I'm going to put up some problems here. Hopefully you guys can see those. It says, is it a polygon? If so, concave or convex? So pause this. I want you to answer yes, no, and concave or convex for these, and then I'm going to reveal the answers. Okay, answers. All right, this first one, I put a question mark because this is actually like a curve right here. But it's kind of hard to tell. So technically, if that is a curve, and we're saying that's a curve, then we would say this is not a polygon because